here is the chart for sedimentary rocks. So this comes in two different categories. We have clastic. These are sediment that's been worn away down into sand or silt or clay and then been cemented together through that time and pressure and chemical cementation. Whereas the chemical and organic ones are produced either by animals, so coal and shells, calcium carbonate made in shells, or chemically it has been dissolved and reformed. So I'm going to start with the clastic ones, and they basically start coarse grained and go down to very fine grained. So shale is basically clay, mud, that has been turned into a rock, which is what this one is. So it's really hard to see any crystals in it. It's just mud, and it's been laid down in layers, so you usually can like break it off in layers because it was laid down at the bottom of a lake or an ocean. And then siltstone is that in between. So this shale is made from clay, siltstone is made from silt, and sandstone is made from sand. So it comes in lots of different colors, but a lot of the times the colors are as red from oxidization of iron. But you can actually see the sand crystals if you have a magnifying glass that works. Maybe not on the screen there. And I can feel the texture. You can almost see the texture right through the screen here. So this is sandstone. And then if you get even coarser grained, you get breccia and conglomerate. When it's smooth stones like this one, this is conglomerate, and when it's angular fragments, it's breccia. So all of these probably were deposited at the bottom of a river or a lake, and then time has cemented those sediments together. This is sort of classic sediments. The chemical is a little bit more complicated. So I'm going to start with the calcium carbonate, or calcite. So calcite is a mineral, but all of these sedimentary rocks are made where the majority of them are calcite, calcium carbonate that's been cemented together. So, like for example, the coquina is pieces of shell. It's like breccia or conglomerate, but pieces of shell have been cemented together. Limestone is medium to fine, medium to coarse grained. And because it's made of calcite, it will react with an acid. So I have, this is 10% acetic acid. So this is vinegar, but it is 10% vinegar instead of 5% vinegar. I haven't tried it with 5% because I didn't have any here, but I will try it with 5%. But it will fizz. I don't know if you guys can see that. If you have calcium carbonate, it will fizz in a weak acid. Which is pretty neat, I think. So any of the calcium carbonates, any of these, chalk. If you have real chalk, so chalk that you have in your house might actually be made of gypsum, not actual chalk. But all of these are made from calcium carbonate, either by animals. A lot of these are made chalk and coquina and oolite. These are all animals have created these. And then the pieces of the animal shells have been ground down and cemented together. So in times of chalk, it's microscopic, so they're tiny. With coquina, it's quite large fragments. Whereas crystalline limestone and micrite are chemically formed, not organically formed, typically, not always. Then when we move down, we have different chemical structures, but it's created the same way the crystalline limestone is, where the calcium carbonate is dissolved and then reformed into limestone. That's how dolomite and chert and gypsum and halite all are formed, where these minerals are dissolved and then reformed. So that's it for sedimentary rocks.